Okay, so here we are. As was suggested, I want to mention you in any time during the presentation, you can write down your questions in the chat, and we will try to answer directly. Okay, so is your the floor, Giovanni? You can go.
So about then again, before getting into QGIS, we have to introduce you about the custom forms, which were arranged using QGIS style. So here we'll follow another brief introduction to what are QGIS style for the Geopackage. So are actually forms which allow you to manage lists and a coded list, for instance, and navigate from one pane to another, and which are all related by the actual relation stored into the relational database. So, for instance, forms are customized with tabs which are according to the semantic model and semantic data stored into the database. For instance, observed and derived, list different tabs for according the content. And for instance, observable properties can be both numerical or coded, and has a numeric value is an observable property. Then a range, a value domain should be listed for each observable property, or if it's coded, a code list should be listed. So that allow you to ingest just value which fall into the range, a domain minimum, maximum range for a certain unit of measurement with these properties. That activate triggers and allow you to see if why the Geopackage give you an error for inserting this value, for instance. And the same about coded value, the list is presented to allow you for the ingestion of the proper value for this property that you are observing. About the Geopackage, the QGIS you should version you should install is the last. So in this case, it's 335 for Ryzen, because not every functionalities are can be managed with previous versions. So if you open your QGIS installation, download, you can connect to the Geopackage by, you see, usually QGIS Open has an empty layer, but allow you to browse different sources. In this case, you have to select Geopackage and New Connection. Then you got to search where you stored your Geopackage template and open. The Geopackage is now there and can be navigated exactly as it was by means of the database management system. You can see all fields and properties for each table, both relational tables and the geographic entities. Just in the browser, you can see the project. So by double click on the project, the layers are into the layers and are mapped. So not every entity is listed under layers because just the relevant ones are listed, but are all stored into and visible, so can be navigated. Since there are custom forms, then you can navigate within one or the other form just using the custom forms. About to get a view of what's there, let's start. Plot can be defined. Plot types are trial pit, borehole, and sample. Please refer to the INSPIRE registry for definitions. The soil site and soil body. Soil body are the style is colored according the reference soil group coloring system proposed by World Reference Base. And to open a table, just select it, open, and you can select the row. In this case, we are just looking about the soil-derived object, which is actually the map. So, in this view, you can see this is the bidimensional table, but you can swap from the bidimensional view to the form. If you open the form, the description is there, and the relation among the map and the soil profile is there. So you can actually maintain the information of which observed soil profile or derived soil profile or soil body generated your map. So let's now, then another thing you can do is, for instance, the soil profile. You can both see the form or the table view, and you can, for instance, export your table in several formats, both geographical or flat sheet. For instance, comma separate value. Choose the name. So choose the folder. And for instance, decide a name, QGIS. And select use alias for exported name. This allows you to decode, to associate the values of which are related to this entity without exporting the keys. So by doing that, you can now export, and it will take a while because I didn't select a few of them. So it will work, and we will see later what's the result. By now, we just give a look to, for instance, about soil plot, open attribute table. So this is the bidimensional view, and this is the form. Select, you can select, yeah, now the export was performed. And for instance, wait a minute, I just open it again. For instance, you can select and go to zoom to selection. In this case, you can see two different soil plots were placed in the same soil site. So from the soil plot, open, attribute table, filter, has selected feature, you are there. This is the feature we selected before. Sorry. And you can navigate from the soil plot to the soil site. So this is where the soil plot is placed. So, and you can see the two, and you might select the other one. So you can navigate from one entity to the other. So now and see, for instance, the soil profile related, observed into this plot, which is the location is Contrada Gorki, for instance, and is described by a local ID, a namespace, which is the domain of your database, and the version is ED. Dates are stored always related to the any observation, and For instance, we can see that this soil profile described in Contrada Gorgi was described as Lubisol according World Reference Base 2006. So now just get back to Zoom and, for instance, try to edit a new soil site. So with right click on the entity, toggle editing, and choose new add polygon feature. Left click, 1, 2, 3, 4, and right click. As I explained you got to describe locally the namespace and version. In our case, this is a test local ID, so I'm just prepared a local ID for this test and has namespace. We are referring to InfoSwoli and version is 1. Soil site types are general or specific. In this case, we choose specific soil survey. As you can see, dates are already there, but for sure it can be also changed in any part. Before to proceed, we have to say OK, save, and stop. Now the soil site is there, and we can proceed with the soil plot. So right click, toggle edit. In this case, add point feature can be selected, and the soil feature location can be added. The form open with auto-generate ID, and we can create the local ID of the soil plot, which is then again the namespace and the version. Soil plot types can be borehole, sample, or trial plate. In our case in Sicily, we just have trial plate, which are, for instance, mini pit or profiles, while you can adopt different survey type, for instance, samples. So we choose, in this case, a sample, and it might seem that the proper soil site was identified, but that's not the right one. It's just the first of the list. You have to select the test one, the one you already created, and now the relation is there. About the date, you can choose, actually keep it or change it if you like. And before going further filling, you have to generate it. So save and stop. Now we can open attribute table. The feature is there. So now we can describe, for instance, a soil profile related to this and new entities we already created. And then we can, we just select the local ID, for instance, test. This is the one we already inserted, and we select it. So in this case, the location is there, the one we just created, and we can add the new profile. So first, the edit mode, then the add child feature, the form is there, and we can enter the local ID. And this case is actually an observed soil profile. So the namespace is the same, and the version is there. Dates are entered automatically, and since it's not derived, we don't need to flag it, and that means that this was observed. We can enter the reference soil group according 3 different classification, 2006, 14, or 22. We select 2006, which is the only one maintained by INSPIRE right now, and assign it to the soil profile, This is an original classification. It means that it was assigned into the field. If you unflag, you can change it. In this case, the soil profile is already related to your plot. Then, okay. Save and stop editing. So, about the soil profile, open the attribute table, search for tests. There is our, sorry. In this case, I didn't listen the location. So, location is local identifier, which is test, yes, editing mode, and test profile location. Save and stop. So, reference soil group is already there, while no qualifier was listed. We can add now a qualifier, simply acting the editing mode, add child feature, test profile location is okay, position, and select the, for instance, calcaric, and so on. Done. Save and stop. So in the manual, you will find all the paths to go through a profile element, data stream, and observation. We have several other functions to show you, so we don't perform the complete insert of a single profile with elements and observation, but not now. Just show you some other functionality. For instance, you might be interested in knowing how to give a style and to view the properties, your own properties, which are related to a single soil plot. But if you open the table, you can see that observations are not directly linked to the location. So if you want to look at properties and choose, for instance, graduated style, the only value you can assign to a graduated value is the date. So it's quite unuseful. So how can we give a style to properties? We suggest to use the model designer, which we won't teach you about. We just prepare a model, but just to show you about this functionality, which is quite powerful and useful. In our case, we will open a model we already arranged, and we will see how it's done. In general, so it's a graphical model, so it's not that complex, but hey, don't get too much inside how to build it. In any case, you should relate both the profile element, data stream, the observation, the process, the unit of measurement, and perform some statistics and produce some results. That is the case. We simply run the model and perform the query. Right now, the query was produced, but the result is not yet there. Why? Because we performed this query over more than 2,000 observations. So it takes a while to produce the result, the geographical result. As the blue bar turns to be complete, then you can close, and the result is generated. Now we can complete, close, and the new table is there. You can open and see the result of the statistics on the whole soil plots. But how to relate it to soil plot? For instance, by properties, just joins, add, you keep the new table, you choose location and guide key. And okay, apply and go back to symbology. Right now, you can choose gradated and the whole list is there, and you can choose, for instance, median or mean. Choose the style by instance, classify and apply. And your plots are colored according the median contained or of organic carbon in this plot. So then next, we can now check about the exporting result. We exported into the folder. Sorry. We exported the soil profile by CSV, both by dbeaver and QGIS. Let's check about the results. So it was exported by means of dbeaver. Keys are there describing dates and so on, and all the data. So it's quite a frustrating table because it's good just to replicate the database content according, not to give real information. While the soil profile exported by QGIS, dates are human readable, and alias has been adopted to describe the content of the whole data set. So that's the exporting the alias instead of keys is actually the way of sharing your information, and QGIS allow you to do this. So I suppose we are quite in time. If there aren't any other question, we might
we are full in time, Giovanni, but I think that yeah, I would ask people to intervene somehow, because you have explained a lot of things, and I think that there should be some question on this that you have presented up to now. But I asked people to write in the chat, but anyone wrote down. So just to...
We can,
yeah.
in any case, if there are no other questions, when I can show how to add a new profile element
Yes,
to
exactly.
describe and so on. Since we are quite in time, we have time to go further. So we prepare and go further with the whole description.
Okay.
Let's try to do it. I hope. So about the profile element, let's enter a new one. So open attribute table, choose toggle editing mode. choose add the feature mode and assign, sorry, the local ID. So this profile element, it's part of test soil profile. Is it a layer or a horizon? We might give it, if it's, sorry, give him a name, is a profile element. Always, it's quite boring this about the namespace and the version, but it's request to generate the INSPIRE ID. Give it the limit, for instance, lower value, upper value and lower value, 0 to 20 or 23, and give it a date and save and stop. Now, let's filter it about this part of test. This is the profile we just entered, and we can now enter the particle size fraction. About particle size fraction, according to INSPIRE, it's not requested the three main particle size fraction. It's not mandatory. So it's up to the one who performed the entering data is to define how many particle size fraction describe his own data set. Might be 3, might be 5, might be 7, and what else. But what is mandatory is giving about the content, for instance, 7, and define the particle size fraction range. For instance, 0 micrometer to 50. It's about clay. And we save it and add another fraction. For instance, 25, 50 to 2000. It's about sand. So, and so on. You can add every other fraction you need, describing your profile element. So now save and stop.
Giovanni, we have a question from Rosario.
Okay, Can you read it?
I just explained you. It is about the entering of correct figure for particle size class. As you have said about the range, the trigger that are inside the. So if you can explain about this topic.
Sorry, maybe I read it because I see also Kathy has.
Yeah, this was a previous
something.
question, but we have already answered to Rosario that
So
you were inserting
about
horizons. Yeah.
yes, about wrong range of size. Actually, it's up to the one who insert data to give metadata of his own data. So it's a question of accurate describing your data. It's up to you. The mandatory thing is that the sum of any fraction should be 100. Otherwise, it returns you an error if it's higher than 100. And it doesn't give you an error if it's less than, because another fraction which you didn't describe might not be yet there. So Rosario, please ask by voice, otherwise it's more difficult to me to read.
Thank you, Giovanni. Because I saw that the system take automatically the description. You put the range of clay and appear clay, okay, 7% clay. So there is a reference table with all the range of classes. And I will ask if the system allow the errors or not. If I put an error range, because this traditionally, you know, in previous database, we have a menu that we have sand, silt, and clay in international mode, or maybe also in national classes or other classes or sites, because are different. For example, international and those classes are different. They have different limits, of course. And but respect to the traditional database entry, in this case, you have to know the limit of the class. So it's quite is a step further. You must know the class, but and if you are wrong, there are no controls in the system to. If you are wrong, means sorry. If you are wrong, means I explain. If you put wrongly some limits that doesn't correspond to any class that you have USDA, national existing classes.
You know about, I'm replying, sorry. You know, by Glossula, there are tenth of classes possible. So it's, you just, the system itself, it collects any kind of range you decide to store. But the accuracy of the data you are inserting is up to the one who insert the data. But the system can collect any kind of class he decides. It should be, for sure, coherent with the system you adopt. But actually, the only point is the total should be 100. So, for instance, could even be just 2 classes instead of 3. There are some classification which describe soil as fine and coarse. There are 2 classes, but please define the range of each of your 2 classes. So it's such flexible, and such flexibility gives you the mandate to describe your data according your system. So it's quite boring, but flexibility requests this.
Yes, but we are not discussing about flexibility. We are discussing about the error.
The error, the human error is always there. So if for instance, the sum is not 100, then you can choose to avoid this data. So this profile, the whole profile, is dropped out any further elaboration of your own data. If it doesn't work, then just keep it away.
May I,
Yes.
Giovanni, we have to also answer to a very important question we have received. I also invite Stefania to answer if I do not answer properly, but it refers actually to the description of the process, correct description of the process. So yeah.
Before I reply, I would like Kathy to reply, because she really find this model. So she might add something I didn't say. So please, Kathy.
Which question? Because I'm confused right now that we have at least 2 or 3 different questions. Adding the clay to the particle size broke my brain. So what is the question? I mean, we can add fractions of clay, silt, and sand. To my memory there, we do not have a check to 100%. That I'm not sure on. With the particle size fraction, I've just been through this type recently. And there, I mean, the particle sizes you put in the particle sizes you are differentiating by, whatever your classifications are. And as I just wrote in the chat, I mean, if you screw up in the particle size, if you say your particle sizes are from 2 to 3 meters, these are no longer particles, these are boulders, you're a geologist. You're lost. But what these sizes are, this depends on your national or local classification scheme. So it could be from 1 to 5 millimeter, it could be from 1 to 10 millimeter. And you set up your size ranges, then you figure out what fraction is in which size range. The sum of these fractions should be 100%, otherwise you've missed something. So is that the question, or what is the question I'm supposed to be answering?
I would like to integrate, if I'm wrong, I hope not, because actually the in between different fractions, depending on the process, I mean the method that is applied country by country, you may have different value to distinguish between the different fractions. So, but this is the method, I mean, the process. So it is up to you, as Giovanni said, to describe properly which is the method that you have applied for. And then based on this, you report the value.
Exactly. So, I mean, there either we've got this method already set up as a code list. Alternatively, you need to describe that properly. And that's one of the benefits of using the O&M parts of this system, that since everybody is using different methods, we don't have to predefine that. People can really report what are they actually doing.
Yeah, I mean, I don't know why Giovanni chose really texture, because actually we have implemented in Sicily up to now only the two properties which are exposed in INSPIRE, so pH and organic carbon. And so about, I mean, texture, we are going also to explain in the fourth workshop in January, the procedure also to include different registries and different process that you may need. And so this, I suppose that it was not foreseen today, but in any case, we can also answer to the question, good question that came.
Short note on the procedure. The particle size fraction is not done via O&M. This is a dedicated attribute from the INSPIRE data model. Therefore, for this, it is not possible to provide the methodology. There is no process information on how you have done this. This is not foreseen in INSPIRE. If you wanted to also provide that methodology, you would have to provide it again, also as an observation. So, I mean, turning this around, is there a requirement for understanding the methodology of the particle, how the particle size fraction was determined? This you need to say as a soil scientist.
This is the point. This is the point, Katy, because this is a general discussion about all the analytical data that we have, numerical data, and expressed as a numerical value. And I think it's a lack, it's a big lack, this, because generally in database, there are some internal control procedures that if you fix several 100 systems to classify the particles existence, okay, but you must have a reference table of all the particle size methodologies or classes, and you cannot put another, because the system must prevent the error. The same for pH, the same for carbon. If I want to put a value of carbon of 300% or maybe pH 15. So I cannot put the number I want inside, because there must be some references. Okay, we can have in the world 100 of different methods for particle size classes. Okay, but I have to stay in that list. I cannot put one number, the number that I want.
Okay, because I have a few points. The first point is that the particle size fraction, unfortunately, is not being done via O&M. All of the other things, the pH, the organic carbon, all of these additional properties are done via the O&M part. There you always provide the procedure how this was done.
Yeah.
But limiting these procedures, this would work in a reporting environment. When I work for the European Environment Agency and we have reporting data, there they say it must be one of these three methodologies. Then we can constrain that. The problem in this context is here we're working more in a scientific context. And the one thing I've learned about scientists is that they are very creative. And the moment I have nailed down a list of all procedures they are using to determine a specific property, they will invent a new one. And therefore, we have to keep that open. It has to be possible, if you come up with a new way of measuring something, to add that. So that's why we do not constrain the procedures you can use here. It would be possible, like I said, in reporting context, we do exactly that. We then have lists where we see this observable property has to be done by one of these two procedures. But that's the difference between reporting data, which is totally nailed down, versus research data, where I can't tell you how you will do your research tomorrow.
I think that we will address there. We take these notes and we will give a proper answer.
Okay, we might proceed with the demonstration with Hail Studio. And so the Hail Studio export to GML. And then we'll close with the Mentimeter survey. Okay, Maria?
Okay.
Okay. So it's quite easy since the Hail Studio project is there. You just need to install the Hail Studio, import the Geopackage data, export the GML. So just give a look about the project, how it works within Hail Studio. So the source is has to be mapped. The target has to be mapped, and data has to be imported. As far as you import your data, then transformation is performing, and then you can afterward export your transformed data as GML or even as other formats. Choose the proper name, and the work is quite done. So the job of this conversion is there, and just you can connect your own data to export by means of Hail Studio. So here is your own data transformed to GML.